Time travel simulations can solve impossible problems, physicists say. For most of us, the passage of time flies in just one inexorable direction, forward. But for theoretical quantum physicists, time's direction is not quite so inflexible. It's possible to theoretically model, simulate, and observe the backwards flow of time in ways that are impossible to achieve in the real world. And now scientists have shown that the simulations of backwards time travel can help solve physics problems that cannot be resolved with normal physics. Led by physicist David Arvidson Sukur of Cambridge University, a team of physicists conducted an experiment in which the input state can be altered by simulating a backward loop of time that allows them to alter the parameters after they have already been set. These loops are purely hypothetical, of course, but they can be simulated using quantum teleportation circuits created with entangled particles in order to mathematically solve problems. Imagine that you want to send a gift to someone. You need to send it on day 1 to make sure it arrives on day 3. David Sukur explains. However, you only receive that person's wish list on day 2. So in this chronologically respected scenario, it's impossible for you to know in advance what they want as a gift and to make sure you send the right one. Now imagine you can change what you send on day 1 with the information from the wish list received on day 2. Our simulation uses quantum entanglement manipulation to show how you could retroactively change your previous actions to ensure the final outcome is the one you want. Wow, this would be great for exams, wouldn't it? Now, quantum entanglement is a state in which the properties of two particles become linked prior to being measured. Measuring the properties of one particle immediately establishes the complementary state of the other, regardless of how far apart they may be. Scientists have even been able to influence the properties of one particle and observe simulations changed in the other across a significant distance, and that's quantum teleportation. The team's work leverages entangled particles not just to teleport information across physical space, but backwards through time as well. In our proposal, an experimentalist entangles two particles, says physicist Nicole Junger Halpern of the National Institute of Standards and Technology, NIST, University of Maryland. The first particle is then sent to be used in an experiment, and upon gaining new information, the experimentalist manipulates the second particle to effectively alter the first particle's past state, changing the outcome of the experiment. The nature of the closed loop in time also is not the kind that would allow anybody to travel back and paradoxically do away with some grandfather relying on the condition in probability called post-selection, which restricts measures based on set events. The team does not make the argument that such loops exist. Quantum theory, they say, allows for the simulation of these loops that, as a consequence, entanglement can exploit. Their calculations show that the time loop can be successfully exploited only 25% of the time, but this means that it is testable in a real experiment. This experiment is yet to be performed, but it can be done on a large scale by entangling vast numbers of photons, quanta of light, and using time travel simulations to alter their states after they've been sent towards a special camera with a filter designed only to detect photons with the updated information. The detection of these photons would mean that the simulation has worked. That we need to use a filter to make our experiment work is actually pretty reassuring. The world would be very strange if our time travel simulation worked every time. Relativity and all the theories that we are building our understanding of our universe on would be out of the window, Arvidson Sukur says. We're not proposing a time travel machine, but rather a deep dive into the fundamentals of quantum mechanics. These simulations do not allow you to go back and alter your past, but they do allow you to create a better tomorrow by fixing yesterday's problems today. This is published on Physical Review Letters, and it's on Science Alert by Michelle Starr. Please leave your comments. Thank you for your support. support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.